74. Today we're talking about choosing the best power for your field day station. My name's Chris Mattia. My amateur radio call sign is Whiskey 6 Alpha Hotel. Today I am joined by my esteemed colleague Dan, NR6V, and driving down through the Central Valley of California is David W0DHG. He may pop in just a little bit, but he is on his mobile setup while he's heading down through the Central Valley. So without any further ado, let's get into today's topic a little bit. First thing, as we normally do here, we'd like everyone to send us a WinLink check-in. Send it to all three of our call signs. Send it to W0DHG, NR6V, W6AH, and our tactical address of WaveTalkers. Use the standard WinLink check-in form. We'll step through that process here in just a second. And in the comments section, let us know how you're planning to power your field day station. So with that, let me go ahead and pull this off of the screen there, and I'll just move myself down into the corner. Whoops, and we'll bring up the laptop here. And we'll quickly walk through the process of sending in a WinLink check-in. So what you want to do is make sure you've got WinLink Express opened and running. You're going to come up here to the upper left. You're going to click on the new message button. It's going to bring up that new message window. This is going to look just like a regular email. You're going to come over here to the select template button. Give that a click. Your template manager should open up for you. And what you're looking for is the standard templates. Go ahead and give that a click. And then down here a little further, you'll find the general forms section. Give that a click as well. When you do, what you're looking for is down at the very bottom of that list, you'll find one that says WinLink checkin.txt. Go ahead and give that a double click. Now, if the demo gods are with you, it should open up your web browser of choice. It should look something like this. When you get started filling out a form, you always want to click on the date and time field so that it sets the form to your computer's current date and time. That way, your form shows up in the right time slot when it's mapped. We're going to go ahead and click OK. Now, for the status, just go ahead and let us know that this is an exercise. Let us know the band that you're connecting from. If it's one of the amateur bands, just go ahead and select those. If you're going to send this in via Telnet, then go ahead and leave it set to NA. That's I'm using the internet. Under mode, you can select the mode that you're going to send it in. I'm going to leave mine set to Telnet. Here in the send to, this is where you add all of our call signs. Just separate each of those with a semicolon in order to add multiple addresses into one field. So our call signs again are W0DHG, NR6V, W6AH, and our tactical address is WaveTalkers. This allows you to send one message, one WinLink email, and it goes to multiple different people. Then down here in the call sign section, let us know all the operators that are there with you. I know some of you have multiple operators that are at your location. Go ahead and list all of them here in their call signs. Station contact, this is going to be your name or your handle, and station call sign, that's your actual call sign. And the location, you're going to let us know where you're coming in from, and the latitude and longitude should be filled in automatically for you, either as the center of your grid square, or if you've got a connected GPS, it should have the more precise GPS coordinates for you. This is that comment section I was talking about. This is where you want to let us know how you're planning to power your field day station. When you get through filling all of that out, go ahead and click the submit button. You'll get a couple of pop-ups here in your browser. Just say okay as you click through those, and finally your browser will go blank. When it does, you can go ahead and just close your browser, and all of the message information from your form should now be attached to this email message here in WinLink. Go ahead and post that to your outbox using the button in the upper left, and then come over here to the open session. Go ahead and open that session up and click the start button. And if the demo gods are with you, your WinLink should then take over and should go ahead and send the message in. It looks like we have a few messages that are coming in from around the world. At the end of the show, we'll check in and see where everyone is checking in from. So with that, let's go ahead and jump back over into the talk for today, which is choosing the best field day power. And as I like to say, this is really going to be based on for you and the way that your goals are set up for how you're planning to operate, the location that you're going to be operating from, and your own creativity as to how you wire everything together to keep your station up and running. Now, for many of us, when we think about operating for field day, we're going to be operating usually with a group. We'll have a fairly large operating setup, perhaps multiple different antennas, perhaps multiple different radios and stations that are going to be set up. You may even be operating in multiple different modes where you're doing some digital, you're doing some CW, you're doing some voice. And so you need to be able to power all of that equipment. And your power requirements are going to be vastly different than a typical just going out and operating, say, for a POTA activation, or maybe you're doing a SOTA activation or something like that. That's if you're set up to operate in this type of mode. Now, it is possible that you're going to take your field day approach will be to go out and set up somewhere in the field and operate as an individual. It might be just in your front yard or your backyard, or maybe at a local park that you're going to operate at, in which case your power requirements are going to be quite different than that larger kind of station setup for field day. With field day, it really varies quite a bit as to what approach you plan to choose. Now, for many of us, as I mentioned, we are going to have a bit of a larger setup that we're going to be operating with for field day, a variety of different stations and so forth. And so managing all of that power can be quite complex. It may seem like you need a lot more power to be able to keep your radios up and running. You need to think about keeping your computers up and running. This can be both for logging. It could also be for operating in the digital modes and so forth. Maybe if you're operating in digital modes, maybe you have some powered devices such as a Pector modem or some other type of modem that you're going to be using with your radio. So you need to take all of that into account when you're coming up with your plan for how to power this. And when it comes to power for field day, there really is kind of, for most people, two major tracks that you're going to likely go down. You're either going to go down the path of the solar panel and battery with battery backup to keep your station up and running, or you're going to go down the path of using a fossil fuel generator of some kind. There are other forms of alternative energy that you could use. You could use portable windmills, you could use portable hydropower. There's a variety of things that are out there. But when it comes to field day, more than likely, you're going to come into using one of these two types of power sources. You could, of course, use commercial power if you're going to operate from your home location. But in the spirit of field day, let's talk about going out in the field and doing operating portably. And we've spent a lot of time on this channel talking about solar panels, solar power, battery backups. We'll review some of those episodes later on in the show to give you some clues as to where to go to get more of that information. But what I want to spend a little more time diving into today is talking about dealing with generators and how you're going to manage those, how you're going to be able to power your station as you're operating for field day, and how you may want to wire your station in general. So this happens to be the generator that I own. I picked up a Honda EU 2200i. It's a really nice, it's a small compact generator, and there are lots of generators that are out there on the market. A few things that you want to look for when you're looking to pick up a generator. You really want one that's pretty RF quiet, and that turns out to be pretty difficult to be able to find. A lot of your portable generators are going to have power outlets on them. They're going to be AC. It's going to have an internal inverter that's going to convert the generated power into AC power that you can then use to power your station. And it works quite well to be able to do that. Let's look around at some of the common features that you may find on a lot of generators. And first thing to look for is, how are you going to fuel the thing and what fuels does it take? Usually at the top, there's some sort of a fill port on it. to be able to use either gasoline. Sometimes you'll find generators that are running on diesel power. There's also ones that run on propane or natural gas or other different types of fuels. But by far the most common is going to be a gasoline powered generator for you. The next thing to look for is where is the on-off switch? And on the Hondas, it's usually down in the front right-hand corner along the side, and it's a really large switch. You want to leave it in the off position anytime you're not operating it, and then you flip it up into the on position when you're ready to be able to start it. Another component that you're going to look for is where is the choke? Now, when you're starting a gasoline engine, if it's cold or the engine is cool, it has not been run recently, and by recently I mean the same day. It could be cold outside, the engine is not being run. So what you want to do is you want to make sure that the choke is on just a little bit when you go to start the engine, and that will adjust the air fuel mixture going into the generator and allow it to start. Now that actually brings me up to one of the things that I really, a lot of us don't think about with our generators. You want to make sure that you run them periodically, because if you don't run your generator periodically, once a month, every other month or so, then the fuel that sits inside of the generator will tend to go bad. And it will be a lot harder to start the generator. I'll walk through a video where I start this generator later on, and I use this one on a pretty regular basis. I try to make sure that I start it about once a month in order to make sure everything is operating and it's ready to go for emergency power. So before you go out to your field day site, if you're planning to use a backup generator or a gas-powered generator, be sure to run that generator and provide any service to it before taking it out into the field. All right, so that's where the choke is. Another thing that you're going to be looking for is the pull start. Now, for the most part, this is just some sort of a handle, a little toggle with a line on it that you're going to give it a pretty good yank in order to get that generator to get started. But that's one of the things that you're going to be looking for. Another thing you're going to be looking for is oftentimes on the front of these generators, many of them will have a switch that will go from full power to what's called eco mode. And what that does is it will actually, in eco mode, the generator will, some of them have some smart intelligence inside of them that it'll idle the generator down at a lower power, so it's consuming less fuel. And then as the demand for power increases, as the generator just detects that you need more power from the generator, it'll automatically ramp up the power that's needed on the generator. So a lot of times I'll operate my generator in eco mode. That way I'm conserving fuel when I don't need to have the power out at full power, and then it'll automatically step up when I do need more power. Another thing to look at is what sort of power outlets your generator has. Now, the generator that I have has two outlets on it. It has one outlet that's a 30 amp circuit, and the other one is a standard 110 outlet. And this is also called an Edison that goes by a variety of other different names. The one that's there on the left, you'll oftentimes find connections for boats and a variety of other different higher power lines, whereas the one that's there on the right for the one that I have works with your standard home outlets. Now, if you're operating from a different country, your generators are likely going to have the outlets that are more appropriate to your particular area that you're operating with. But have a look. Not all generators will have diversity in the types of outlets that they have on them. Some will have, both of them will be the 110 Edison or just the standard outlets that you have. Others will have a mixture of the two. So be sure to take a look at that before you head out into the field. Another thing to look at is usually connected to the outlets in some kind of a on the front panel are usually some sort of fuses or circuit breakers that, just like in your house, where you have your main commercial power coming into your house. If you have an too much draw of current on your generator or on your house on a particular circuit, you may have a circuit breaker that would trip in order to protect the line that's going into there. So look for those. A lot of times on the generators, it's usually a push button. Sometimes it can be a switch that's in there that you'd want to be able to reset if one of the outlets trips. Another thing that you may find on some generators, on these Honda generators in particular, there is another port on here that allows two similar generators to be linked together. Now, in that case, when you have the two generators linked together, what that does is it allows the output of some of these generators to put out a higher amperage of power. So in this case, this outlet, instead of both of them being 15 amps, you would have a 30 amp outlet here, and this would allow you to supply 20 amps of power. And this is AC power on these lines like this. If you don't have two matching generators and you don't have the link cable, then you're just operating two generators independently. And we'll talk more about that later on in the show. Another thing that you might want to look for on your generator, and this is really important for ham radio operators, and that is a ground port, so that you could put a ground rod in and run a ground line over to this port and ground out your generator. It'll help keep down some of the noise. When you look on the top, this is usually somewhere on the fill cap that you've got. There's oftentimes another indicator here, another little switch, and you'll see that this is a little hard to see, but it says it's in the off position right now. And then over on this side, there's a little, it says on. And what this is just a little tiny air valve to allow the cap to close off any air from going in, which will stop the flow of fuel. So when you go to operate it, one of the first things you're going to want to do is you're going to want to turn that fuel cap into the on position to allow the vent within the gas tank to be able to allow air in as the fuel is removed. And that's going to allow your generator to operate and to run. And when you go to start a gas-powered generator, the basic procedure that you want to start, and this is going to vary from generator to generator, so be sure to check the manual for your particular generator that you're going to be operating. But in general, what you're looking to do is first start off with opening that tap. Make sure that you've got plenty of fuel. You want to make sure you're always fueling your generator when it's completely cool. You never want to fuel a generator when it's been hot and running. You want to allow that generator to completely cool so that if you do spill any fuel or if any of the fumes get out, it doesn't cause a spark and cause any bad things to happen. So definitely read your manuals always and check with the manufacturer's suggestions for any safety that you need to operate with your particular generator. But if you go through and you're going to start off by fueling the generator, you put the cap on nice and secure, you're going to turn that little dial at the top into the on position. That's going to allow that fuel to vent. Now you've got fuel that's able to flow through the generator. The next thing you're going to do is down here near the bottom, you're going to reach in and find the on switch. You're going to turn that into the on position. Now that's, for most generators, it's not going to automatically start unless your generator has an electric start. Some of them will have that. They may have an onboard battery and a little starter to be able to automatically start the generator. But for the most part, you're going to have to pull start these. So you flip that into the on position. Next thing you're going to do is you're going to come up here. If the engine is cold, you're going to flip the choke into the choke on position. And next thing you're going to do is you're going to give a couple of pulls of the cord. Just give a nice even pressure, give a nice pull of that, and the generator should start up pretty smoothly without a whole lot of extra effort. Now, once your generator is starting to operate, it's starting to warm up a little bit, then you want to come back up here to that choke line and you're going to want to ease that off and do this slowly. Just kind of start to go off. You'll hear the cadence of the engine start to shift a little bit as the engine gets into its proper operating procedures. And once that's going, you can go ahead and leave the choke all the way off, and you should be good to go at that point. Let me walk through that. I recorded a short video of doing this, and unfortunately the audio is not routing through here. So I'm just going to go ahead and talk over this procedure. So here we go. We've got the generator that's set up, and I'm going to reach up in order to start the generator and turn the fuel into that on position. That's going to release the air valve. Next, we're going to come down on the side, and we're going to turn that into the on position. Now the choke, we're going to flip that all the way into the forward full choke on, and we'll just give it a couple of pulls. Now I'm trying to do this one-handed. I just pointed out that we're in eco mode, and there we go. The generator is actually running at this point. It's just kind of humming along there. We'll let the generator run for just a second, and then as you start to ease that choke off, you'll hear the generator kind of come to its proper idle. Everything should be working fully at that point. You can then plug in your power cables, run all of those, make sure that everything is nice and happy. Next, if you're finished operating for the day and you're going to shut the generator down, one way to do that is to just go ahead and close that valve at the top and allow the generator to just run out of fuel. This way it clears out any of the fuel that's inside of the carburetor or any of the fuel lines, and it burns all of that out. And once the generator stops, it's ready to go. You can then turn off the generator with the switch at the bottom to make sure everything is in the off position. Now, if you're just going to refuel, then you want to make sure that you turn it into the off position and you allow the entire generator to cool down completely before you reach up and you open up that cap to then go through and get your fuel that you've got. You always want to get some fresh fuel, pour it in up to the fill line according to the recommendations, and you should be pretty much good to go at that point. Now, some generators that you get will oftentimes have some kind of way for now an app to be able to talk to them. So the Honda that I have has a Bluetooth connection on it, and there's a free app that you can download from Honda, and you bind the app to your generator, and then it gives you a lot of live feedback. It tells you a maintenance schedule of when you need to do things like change the oil, check the air filter, adjust the spark plug. It'll tell you the idle and how the generator is actually operating. If you do not run your generator on a regular basis, your app will actually, you can see it kind of up here in the top, it'll actually send a little warning to you, send a little notification to your phone and let you know, hey, it's been 60 days, you haven't run your generator, go ahead and get that generator out, operate it a little bit, make sure that it's in full working condition. The more you operate your generator, the easier it's going to be to restart it, and the more you can count on it when you need it in an emergency. Okay, let's look a little closer at those outlets that we talked about on the front of the generator. Here you can see a close-up. This is what the 30 amp outlet looks like. It's got more in a circular pattern here, and one of the legs of the outlet has this extra little piece down here. That way you know you've got all of the poles connected in the correct orientation for that particular plug. You can also see a little bit closer the ground connector that we've got here, that is noting that it's a Bluetooth connection. Here are those circuit protections, and usually these are a push button. You can just push in on that in order to reset those. The outer covers on those are oftentimes a flexible material to be able to reset those. This is what that power outlet looks like in order to be able to connect two generators together. It is a special proprietary cable, and you really do need to make sure that your generators are matched, and this needs to be a feature of those generators. This is what your standard Edison plug looks like. Now, a lot of times for field days, a lot of us will go out and we'll operate with our Aries unit or maybe our ham radio club. We may have a communications trailer, or we may be using an RV or something like that, in which case you're going to want to make sure that you have the proper adapters to go from your generator into, say, the trailer or the RV or what have you, whatever you're going to be operating from. These are not too terribly expensive. Usually they run about $20 to $30 or so for the different adapters, and they'll connect from one plug type into, say, the plug type for, say, your generator or for your trailer or your RV or so forth. And there are a variety of these that are out there. Just make sure that you have all of the power adapters that are needed to run your generator and the setup that you're going to be doing for field day. Another thing you're going to want to have are some heavy duty power cords. You want these to be only as long as you really need them to be. So a lot of times I'll operate with, say, a 25-foot extension cord or maybe a 50-foot extension cord because I want to keep the generator just a little bit further away from the station. But realize that if you get the super cheap power cords, they're going to have smaller wires in them, which means your power transfer is not going to be as efficient. They're going to heat up more. You're going to lose a lot of power over those runs. So if you're going to invest in a generator, you really also need to invest in high quality, heavy duty extension cables and so forth. I have a variety that I use. Some of the heavy duty ones here to run the long run out of the generator, and then some shorter, say 15-foot ones for doing local power distribution at the site where our radios are going to be. Another thing that you may want to consider is to pick up some of these cube taps. Now, these things are really nice. It's just a 3 outlet that goes into 1 outlet. And when you go to set these up, if you're kind of distributing out the power coming from your generator, because more than likely at a field day station, you may be operating multiple different stations. So you might need additional outlets to be able to do that. Take out of your extension cord, plug out of the main extension cord, plug in a single one of these in order to split that power off, and then use shorter cords in order to distribute that out to the various different stations. Now, it is really important, and we'll talk about this more in a little while, to make sure that all of the equipment that you're operating with on AC power, the load of all of that equipment can be met safely by the cables you're using, the wires you're using, the generator that you're using, and so forth. So definitely consult your manuals, consult your, if you need to, talk to an electrician. You may have one in your group to help you make sure that your power requirements are being met properly. When it comes to the very localized power at your field day station to run your radio and computer and other bits and pieces, oftentimes we'll use a power strip such as this with a surge protector on it. And a lot of us have power connectors that have these wall warts on them. And these are a real pain because they take up multiple different outlets, but yet the draw on them is oftentimes really small. So you may be able to have several different devices that you're running, but they have these giant wall warts. And so it's really hard to get everything plugged into a power strip. One solution that you can use for that is to pick up some of these really short 6-inch long extension cords. And when I first saw these, I thought, these are really stupid. Like, what would I ever need a 6-inch extension cord for? Turns out in this use case, they're absolutely perfect because you can take this short little extension cord and plug that wall wart in, and now you can get all of the smaller devices that draw very little current off of them all plugged into a single power strip. It works really pretty well. We've got a link to these on the WinLink page on WaveTalkers. It's a link to them on Amazon if you wanted to pick some of those up. Definitely you want to check your user manuals for all of the equipment that you're going to be operating. Know what the power requirements are, both during receive and during transmit. If you start really thinking about our 100-watt HF radios that we're operating, while we're receiving signals, and they may be operating and only drawing 1 or 2 amps on receive, when they're transmitting at 100 watts in HF, a lot of them are drawing quite a bit of current. They'll oftentimes be drawing 20 or more amps out of that. So your generator may or may not be able to support multiple different stations. You really got to go through all of your equipment, figure out what the overall power requirements are for all of that equipment, and then size your power requirements appropriately. Now, we did spend quite a bit of time talking about this in episode number 34, battery sizing. So go back and check out episode 34 for some more detailed information. We talk about doing this for running off of battery power. We walk through a lot of determining the load. How do you calculate what is the load on all of the equipment that you're planning to be able to run? And there's a couple of different approaches, one of which is to use all of your manuals to be able to add up all of the power requirements. Another is to use some sort of power meter that you put in line, and then you can measure the actual current draw on receive and on transmit. And keep in mind, this is going to vary quite a bit depending on the power level that you have your radio set to. So if you're cranked up to 100 watts and you're operating on sideband, your power levels may not be drawing that full amount that the manual says it is. However, if you're operating digital and you're operating in those 100% duty cycle modes, your power requirements are going to be vastly different. You also need to keep in mind that when you're operating in digital modes, you need to power your computer, you need to power the other peripherals that go along with it. And oftentimes, even though our radios are drawing quite a bit of power, those devices can be really power hungry to be able to do that. You definitely want to check with the battery specifications for the particular batteries that you're operating with. Bioenno has some really good information on their site that really walks through the various different batteries that they have. What are the amp hours that each battery has? What's the maximum discharge that you can pull out of one of those batteries? And then what are the physical constraints, the size, weight, and so forth of each of those batteries? So let's walk through a scenario of how you may want to wire up your power if you're operating from, say, a generator for your field day. Well, the first thing you're going to do is you're going to connect on your primary extension cord. This should be the most heavy duty one that you've got. It's going to be carrying all of the current out of your generator. You're then going to set up some sort of distribution network. You may want to use something like a cube tap or something like that in order to split the power out to the appropriate number of stations that are sized for the generator that you're operating with and for your field day station. You might find that you need multiple generators and multiples of these in order to accommodate all of the power requirements for your field day station. Off of that distribution network, then you're going to go through and you're going to set up the localized distribution, however that ends up working out for your particular situation, where you may have a power strip and you'll have the computer and maybe the radio. You really might need to think through, or you do need to think through very precisely how much power each different device is using to get that total amount that you're going to be operating with. So field day is going great. Everything's going really good. You've got your couple of stations you're running, you're operating on generator power, and all of a sudden what happens? Your computers are still working, but suddenly the displays on your radio go down. That generator is just run out of fuel. You need to be able to switch over the fuel from your generator, or a better plan is to actually have a second generator on standby that's ready to go. And at which time you can take that second generator, you can start it up, make sure it's running, make sure everything is, you go through the same start procedure that you went through for the first generator, and then simply change your main power line over to that second generator, and it'll take a few seconds for everything to power back up, but then you can be able to get everything booted back up and keep operating smoothly as you're doing that. Now, at this point, this is where you want to take that first generator that you are operating and allow it to cool completely. Do not just take it and pop open the cap and fill it up with fuel, the chances of that hot generator then causing a much larger issue, read fire, then you're going to have a problem. So allow that generator to just cool completely. Having a second one is a really good plan. And then once it has, go ahead and refuel it. It's now reset and it's ready to continue operating. Now, in this scenario that I just laid out, it would be pretty annoying to have your entire field day station go down while you're having to change over from one generator to another. So one option that you could have for doing that is to do something like pick up an APS or an automatic power supply. Oftentimes they're called UPSs as well as a universal power supply. And what these do, they've got an internal battery. They're designed to be able to take over an AC load and run it off of that battery for some amount of time. Usually that amount of time, depending on the load, is usually anywhere from 10 to 20 minutes, which is plenty enough time in order to get your additional generator back up and running or come up with another power solution. So this is what that would look like in this scenario. Instead of putting your, say, that cube tap that I talked about earlier, instead of putting that in line to distribute your power out to the various different stations, you would just put in a UPS or an APC, whatever you want to call it. You're going to put that in line so that your main power line coming out of the generator is connected to that. Now, when your generator runs out of fuel, a couple of things are going to happen. First of all, your UPS is going to automatically take over the load that the generator was supporting for all of these. Now, you do want to make sure that your UPS is properly sized to be able to handle the load of all the equipment that you're going to be operating. So check the manuals, check all the technical requirements that you need to in order to make sure that you're able to do this. But what you're going to see and you're going to hear is that UPS is going to start screaming. It's going to have some kind of usually a red light that's going to start flashing. And oftentimes they'll have some sort of an alarm that'll be going off. You'll oftentimes hear the relays inside clicking as it's clicking back and forth and it's turning that UPS on at that point. When you hear that, that's your cue, and you should be monitoring your fuel lines and knowing kind of how much your generator is able to operate. But once you get to the point where your UPS has taken over the load from your generator, that's the time to go ahead and bring that second generator up, get it started, get it operating. You can then smoothly change that line over, the main line, plug it into the new generator that's operating. And there you go. Your generator, after a few seconds or so, the UPS, the light will go off, the alarms will stop. And what'll start happening is the UPS will automatically start recharging its internal battery off of the load coming from the generator, and it'll continue to pass through power out to your peripherals. Now, on these UPSs, keep in mind that there are oftentimes two different types of outlets on them. One type of outlet that's on them is a battery backup managed port. So you want to plug in the critical items that do not have their own onboard batteries into those ports. So such as your radio that you need, or maybe your modem, such as something like that. Your computers, oftentimes, if you're using a laptop, you can oftentimes plug those into that second port that's on the UPSs, which is just an unmanaged port, so that even though the generator goes down, the UPS is going to keep things like your radio up and running. Your laptops would continue running off of their internal battery. That will help you manage the power a little bit better coming out of the generator while you're doing that. And of course, at that point, you can refuel the second generator, get that up and running and ready to go. Now, this is what that looked like when we were operating at Baker to Vegas for the medical radio network. We literally had redundant power set up. We had two generators that were sitting there. They both had the feed coming directly from the RV. And so we could, as we were monitoring the power, when one power would go down, we could just start up the other generator, switch over the power, and we were running pretty well. A real key thing that you want to ensure that you have for your field day station, if you were doing really any field day station, is make sure that you have a fire extinguisher that is located very easy to be able to get to. You don't necessarily want it right next to your generator. So if you did have a fuel or have a fire issue, you don't want to have to run into the area where the fire is located in order to get your fire extinguisher. Have it between where your operating position is, in this case it was inside of the RV, and where you would be coming out to the potential issue that you would have, so that you could easily get it and you could stay a safe distance away in order to be able to operate it. Be sure you know all the safety procedures and how to operate a fire extinguisher properly. It's a really good thing to know how to do. Inside of the RV, in order to have full power for the station that we were operating, we used a pair of 60 amp hour batteries, and these were literally there just to be able to hold over during our power changeover. So if we did have a problem with the generator, it would automatically switch over to battery backup, keep the station up and running. In this case, we were operating a mission critical station. It was a repeater that was supporting the medical radio network. For your field day station, it's still a good idea, especially if you want to keep operating, because you're going to be modeling what your real emergency situations would be. This is how we had that wired up. For that, we had our two generators, both of those fed into the RV. The RV that we were using actually had an onboard generator as well. So we even had a third layer that we could fill in here if we needed to. Then off of that single line, we could then plug in our primary and our backup stations. Each of those had battery backups on them as well in order to keep that up and running. Now, what if you're doing all of this without having a regular generator and you're going to be doing this off of solar? Well, you can set up a very similar type of setup by having multiple different batteries set up and then using a combination of different controllers. So in this case, these are both controllers by Buddy Pole. And I just got some word from the folks at Buddy Pole that they are going to have more of these in stock before the end of the month. Both the Power Plus as well as the Power Mini and the Power Plus. We should have more of those. They should have more of those in stock before the end of the month. So these are definitely something to be able to take a look at. Now, what these two different devices do. First of all, the first one over here is called the Power Mini. And what this is a solar charge controller. So what it's doing is it's got solar panels that would be connected on this line. So you got your solar panels are coming in. That's feeding and providing the main source of power, such as your generator would be if you're running a fossil fuel generator. In this case, we would be running solar panels going into this device. And then your primary battery would be connected to the battery port on this. And what this device is going to be doing is it's going to be managing the charge that's coming in from your solar panels, and it's going to be charging this battery at the proper level, and it's also going to be supplying power to your devices out of the right-hand side of the device. Now, what I've done here is I've just gone ahead and I've connected one of the power out ports directly into the power in port of what's called the Power Plus. Now, the Power Plus, this is kind of a universal power supply in a small portable setup. They're really nice units. What you would do normally is you would have your DC power coming in from, say, your generator, and your DC power supply could be coming into this top port. In this case, I'm feeding my DC power from the Power Mini and this primary battery. Then there's a second charge port on here where you can run a second battery, and the Power Plus is going to automatically both charge this battery off of the power that's coming in from this line, but it will also automatically switch over to this battery in the situation where you lose power here. So let's say you've been operating your field day station throughout the day. It's now well into the evening, and the sun's down, you're not actually charging. So you're running all off of battery power at that point. You're going to be pulling your primary power off of your first battery that you've got. Once this battery is completely depleted, then the Power Plus is going to automatically switch over to your backup power system. When you do that, you'll see that the indicator lights here will let you know that that's taken place, and it gives you the opportunity to then come in and perhaps swap out your primary battery that you have, or maybe start thinking about different ways that you could better manage your power that you're operating with during your field day. This might be things like lowering the power output that you're doing. It might be to suspend some of your digital operations so you can conserve power a little bit more and using some more efficient modes such as sideband or CW. And so that's pretty much how this works. All of your equipment would then be plugged into power ports that are located up here on the top. And so it gives you a complete power management system. Now, there are other vendors out there that do kind of similar things, but there's not really a whole lot that does all of this in such a clean, small package that is also RF quiet. So this is what a complete station may look like for field day. This is usually how we operate our solar power gateway as well. So we would have, we usually use either a pair of 60 amp hour batteries, or we'll use an 80 amp hour battery as our first primary battery, and then have the 60 amp on standby to be able to swap in if need be. But here's the power being distributed out of the Power Plus, and you can see one line is going into our small computer that we're using. We're using USB-C power to power the small display that we have, internal battery for the keyboard, or maybe it's a USB powered keyboard, and then our radio is also plugged in. Now on the Power Plus, there are two circuits on there, an A circuit and a B circuit. So I would suggest splitting the power out. So maybe your radio is on, say, the A circuit, and your computer equipment is on, say, the B circuit. That way you can better distribute the power that's coming out and better manage the load that's going on. Now you may be wondering, okay, how do I size the proper battery that I'm going to need for field day and manage all of the charging that I need to do? Well, if you go to Bioenno's website, you go to their frequently asked questions page, they do have a pull sheet that goes through and it shows you the different sizes of batteries that you may want to select, and it shows you the different loads that are typical for both normal operating, and they have a category specifically for field day on that PDF file that you can download. I'll put a link down in the description for this video once we get it published, and I'll also put it up on the WaveTalkers website so you can get directly to that article. And we also went into a lot more detail of this in episode number 34, where we talked at length about sizing the batteries for your particular station. All of that is going to apply to your field day station. So we'd suggest go back and watch that episode again. We published it last summer. And we did a lot of work with that. We also did an episode number 35, where we talked about portable solar panels, portable solar power for ham radio. And we went into a lot more depth about how to set up and how to wire your solar panels, whether you're going to wire them in series or in parallel, how many watts of power you're going to need to keep your station fully charged. One thing to keep in mind when you're operating on solar power, or we're operating on emergency power in general, you want to consider a couple of things. During the day, when you're operating your field day station, you want enough solar charging capacity so that it can completely maintain the load of what you're operating, how much you're taking out of the batteries. And you also want some that's a little bit extra so that your solar panels can charge your batteries. So you need actually an excess of power capacity in order to properly charge and keep a solar system up and running. You also want to keep in mind that once you get into the nighttime and you're drawing all of your power out of that solar, out of those batteries that you've got, when it comes to first thing in the morning, when the sun comes up, you want to make sure that you still have enough battery power to get you well into the morning. to be able to cover that handover as the sun's coming up, you're not going to be getting the full output out of all of your panels. So you may need to oversize, or you may need to have some additional battery backups ready to go to handle that changeover time. And then you still need enough power to be able to recharge for the next day. Now, when we're doing this for field day is a 24-hour operation. So you really do need to be able to get through the morning and continue operating into the next day to keep that going. So definitely something to keep in mind. Another episode that you may want to check out is episode number 36. We called it Power Pole Everything. And we went into a lot of detail about how to create, how to use power poles, in particular, the Anderson power poles, in order to make all of your connections. Now, as ham radio operators, especially for field day, when you're going to have lots of different operators coming together and working on stations together, you want to be able to interswap your gear with other folks. And if you're using a standardized power system, such as power poles, that's going to make that a whole lot easier to be able to do. So you may want to check out this episode to find more information about that. Finally, we went in episode number 57. We started talking about WinLink gateways, the first episode of the new series on WinLink gateways that we did. We went into a lot more detail about how to be able to set up and manage the power to ensure you've got continuous power for a WinLink gateway. And all of that would apply to your field day station as well. So it's another episode that you may want to go back and check out. And that's what the overall station for field day for power requirements is likely to look like for you. And really, you just need to think about what your particular goal for field day is, how you're planning to operate it. Last week, we talked about the various different ways that you may want to go and think about your field day operations. Are you trying to win the contest that's not a contest? Or are you just trying to go out and test out your equipment and make sure that you can operate? Maybe you're just going to go out in the field and you're going to do some simple operations just yourself and be able to operate for a few hours. Your power requirements are going to vary quite a bit depending on how you actually approach your field day situation. And with that, what I'm going to do is I'm going to kick it back over to Dan. Dan, you want to talk a little bit about your field day setup and kind of what your power is going to look like?
You bet.
Your audio is really low.
Let me try something.
Hang on. Little minor technical difficulties. We're having some, let's see if we can get it straightened out. And we're going into the infinite world of operating. Let's see if we can get him back up and running. Oh, there you are.
Okay, I switched to the mic in my webcam.
Okay.
Okay. Let's get rid of that. Whoa.
There you go. Oh.
Okay, so this is the site we're operating at. This is Fire Station 109 on the relatively famous Mulholland Drive. We're operating on the right side of the image here, which is the concrete slab at the front there. Used to be, back in the old Mountain Fire District days, that was a bulldozer shed for the wildland firefighting. And they're now kept another place, but the slab's still there. We may operate some from that location. However, there was a large tree in the center of this picture, which went down in the storms this year. And that was where we anchored a lot of our antennas. So we're having to make some different changes. But also there was a huge beehive in that tree. And what they've done is they've captured those bees and put them into wooden beehives and stored them on this concrete slab. So we're not sure how safe it's going to be to operate there. But on the right here is a old helipad, which is no longer used. The neighbors sort of griped about the noise. So we're going to set up our comms trailer on this slab. And then we've got this large dirt area here where we can set up antennas and such. So, but we may be spread out throughout this area. In the past, we've worked primarily from batteries, but we've relied on generators to recharge the batteries. This year, we have a little bit of a unique situation in that for the grant that we got to put in the system that we've talked about for the solar powered Arden network based notification system that we're installing, we bought a number of 100 amp hour battle-born lithium iron phosphate batteries to put in each of those nodes. And since we've only deployed about half the nodes, we've got a bunch of batteries this year. So we're thinking we can probably operate totally off of battery. And we do have generators. We've got a couple of 2,000 watt Yamaha generators, inverters. Those are very similar to the Hondas. And we have one 3,000 watt. Not sure whether we're going to take that or not because it's pretty heavy. But so we'll have plenty of generator capability should we need to recharge those batteries. But under the tree area here, there is, it's hard to see it, but there's several level pads that are sort of terraced. And in the past, we've operated on those pads as well. We put our HF stations in there. So we'll have probably at least 3 different operating positions, probably 4 or 5. So each of those will require batteries, but until we deploy those batteries for the Arden based system, we'll have the luxury of having those to use for field day. So this may be the only year we have that, but it's been a wonderful location for us. The fire department is very welcoming. They allow us to use their bathrooms. We've even brought supplies and they've cooked breakfast for us on Sunday mornings. And they're real happy to have us there, which is a really nice feeling. But so the bottom line is we're probably going to be totally or nearly totally battery operated with lithium iron phosphate batteries. If we need to, we'll use inverter generators to charge the batteries. And that may happen. Last year, even with fewer batteries, we did very little running of the generator. And if we do run it, it'll probably be in this slab area just for safety reasons, so we don't have to deal with any concerns about setting the brush on fire. I think our biggest safety concern this year is going to be rattlesnakes. With all the rain that we've had, the vegetation is fairly high, a lot of rodents this year, and with rodents you get snakes. So we're going to have to be pretty careful, especially in the brushy areas under the trees here. And from what I understand, the brush on the terrace level up by the helipad has been cut down very low this year. So basically that's what we're doing. Pretty simple this year. Back to you, Chris.
Thanks, Dan. I'm just kind of skimming through the chat briefly here, and I saw there were a couple of questions. I want to kind of address a few of them. First of all, somebody asked, how do you know if a generator is RF quiet or not? Unfortunately, the only real way to be able to test that is to set the generator up, connect up your radio, start operating. You want to do this well before field day. Plug it in, and a great way to be able to do that, bring up something like an ICOM 7300 or an ICOM 705, something that's got a really good waterfall display on it. And when you turn that generator on, you'll be able to see the noise floor jump on it. And depending on whether or not that generator is RF quiet or not, you will see that jump up quite a bit. Now, there's all of the normal ways you can go through trying to mitigate that. ferrites and toroids and all those sorts of things to be able to help mitigate some of that, keep the generator further away if you can. But keep in mind that this becomes a real challenge, because the further you move the generator away, the larger the extension cords, the heavier duty that you're going to need in order to get that power moved back over to your site. So definitely take that into account when you are considering your generators. Some people talked about the Hondas being pretty expensive, and yeah, they are pretty expensive. But I have found that at least the Honda that I have is pretty RF quiet. It's not completely silent, but it's at least manageable to be able to operate RF stations with. Somebody else mentioned, hey, it'd be great to have 2 generators, but I don't have the budget to be able to buy 2 generators. Well, that's in the situation where you're operating as a group, and more than likely multiple operators within your group are going to have some sort of generator that you can then switch over from one to another, as opposed to only having one. Obviously, if you're just an individual trying to operate field day, the amount of equipment and the resources that you have are going to be scaled appropriately. This is if you're starting to work on a much larger kind of scale. Remember, for field day, we're trying to model what it would be to actually deploy and go out and operate in an emergency situation. And you're not going to be doing that more than likely entirely by yourself. You're going to be working as a team. So when we start thinking about all of the setups that I'm talking about here, it is a pretty large setup and a lot of resources that it takes, but it is much more manageable when those resources are distributed across your entire organization. Many organizations are going to have a lot of this equipment that they've purchased together as a group. So you may have a trailer or a mobile command unit that you're going to be operating from, and you may have a lot of these components already built up. Somebody else mentioned that the best way to store a generator or any gas-powered device is to completely empty all of the fuel out. And that's absolutely true. Make sure that you've got your fuel all out, especially if you're going to be storing it for long periods of time. Here in Southern California, I will keep mine fueled up all the time, so that I can make sure that if I need power, I'm able to start the generator, keep it in a safe location that's proper and appropriate for being able to store fuel in. And I don't leave that fuel in there all the time. I do run my generator fairly often. Anytime I'm doing, for instance, like if I'm operating a show or something, a lot of times I'll have the generator queued up ready to go in the background in case the overall mains power goes down. So there might be other times where you're needing to use generators as your backup power source to go. Some other folks mentioned about the weight of the wires to be able to use. If you're at all questioning that, check with a local electrician in your area to find the proper sizing for the equipment that you have and the lengths and the runs. I don't even want to get into saying, specific different models that you would want to have, because that's really going to vary depending on the amount of current that you're needing to draw out of that. But check with your local authorities for what that should be. And with that, I think that gets through most of the questions, most of the things that are out there. I see somebody else mentioned Honda means also pure sine wave. It's something else I didn't mention. There's different types of ways of generating AC power. There's a pure sine wave, which is what you're really looking for. And there's a kind of a modified sine wave or a simulated sine wave where the power has got a lot more fluctuation and it's not quite that smooth power. When you're running RF, you really want to have that pure sine wave inverter, and not all generators or inverters are going to have that. So it's definitely something to be able to look at. Thanks. Pulse width modulation is the other term that I was looking for. It's really nice to have everybody available here. And by the way, if you would like to join us in the Zoom anytime for any of our shows, then go to wavetalkers.com, scroll to the bottom of any page. There's a join us link. fill out the form. We send out one email a week to let you know what's the link for the live Zoom audience that we have, where you'd be able to participate in the after party and the live chat that we have going on here. With that, let me jump back to my walk-up station here. We'll do another check here real quick to see if any other check-ins have come in. And I've been checking on these in the background, so I think I've gotten them all at this point. So we'll go ahead and map those out, see where everybody is coming in from inside of WinLink here. I'm just going to click on that Maps button here. Select from, you're going to select the type of form that you want to map. In this case, we're going to look at the WinLink check-in forms that have come into my WinLink account. But if you wanted to check this feature out yourself, just look down for the messages section in this drop down, and you can map all of the WinLink messages that have come into your account as well, doing a similar kind of thing to what I'm going to do here. So you hit the display map. It's going to zoom into whatever the last location you were zoomed into. I'll zoom all the way out to get a global view, see who we've got joining us today. It looks like we've got Terry joining us down there in New Zealand, and looks like Roland joining us in Germany. Let me go ahead and zoom back in on North America. I'm going to right click and drag to pan over to this view of North America, and we'll roll over a lot of the other stations that are joining us, so everybody's able to see that we did get your check-ins and where they came in from. So we're super excited to see everybody filling in the map here to get all of the, ideally, we'd love to be able to see where we've got somebody watching from every single one of the states. Would be really wonderful to get to. And we're getting quite a few at this point. We have folks live checking in during the show, sending in your WinLink check-ins and practicing sending in that WinLink traffic every single week. I'm just going to quickly roll down through many more of these to make sure we've got everybody, so everybody can see we got all of the check-ins that did come into us. And I'll zoom into Southern California a little bit because there's a little stack that we've got here. A few more here in the Vegas area. Look at that right there. And one more, get both of those. And then a few here in the LA area as well. So with that, hey, if you find the stuff that we're doing really helpful, then be sure to go onto our YouTube channel and like the content. Subscribe if you're not already subscribed. We do these shows every single week. And if you really find it helpful, then consider going on to our WaveTalkers website and use the Buy Us a Coffee link. It really helps to cover the infrastructure costs that it takes to keep the show up and running all the time. With that, what I'm going to do is I'm going to bring Dan back up to screen as soon as he changes it back over to him being full screen and not me being full screen. There we go. And Dan, any closing thoughts from you today? I know David is driving down the Central Valley today, so he's not on the call with us. He's been popping in and out, I think, a little bit as traffic's been going on. But any thoughts from you for today's show?
Yeah, I think when you're talking about power, safety is a really big concern. It's not hard to be safe, but you really have to think about it, particularly when you're using generators and DC power can bite you, and you got to be careful and think about it. If you're working with a group, take those bonus points for having a safety officer and have that person, monitor what you're doing. And one of my old jobs, we did work in oil fields, and I was really surprised, sort of my first exposure, but we were out in oil fields and there was a safety officer always on hand, and they were God. I remember one instance where we were working overhead with a crane, and something got snagged. It was only 6 or 7 feet off the ground, and one of the guys jumped up on the equipment to try to unsnag it. The safety officer said, "Time out, stop," went to his car, got his climbing gear, went up, took an extra couple of minutes, but it was safe. It was done safely. So don't cut corners if you're putting up, especially if you're putting up stuff up high, towers, that kind of thing. Use the common sense safety. Their power lines, avoid having anything tall enough to fall into those. And this is supposed to be a fun event, and keep it that way by being safe.
That's really key, Dan. Thanks for bringing that up. Safety is such a critical component, and it doesn't matter who you are, how smart you are, how knowledgeable you are in different areas. Leverage all of the resources that you have available to you in order to stay safe. Talk to other operators, come up with an overall plan as to how you're going to establish the safety guidelines and how you're going to be operating your particular field day station or any station that you're setting up in the field. Being able to collaborate with others can be really key. Another channel that's really good, and if you're not familiar with it, check out Smarter Every Day. It's a really good channel, and they just recently did an episode where they were literally shooting two guns to shoot bullets to hit them together and get them to try and merge together, which is an incredibly dangerous kind of thing to be able to do. And as well as they planned that out, one of the things that they did is they brought in additional experts to go through and evaluate the overall plan as to how they were going to step through that process. It's a really key thing to see that in action, to think through how do you plan out and really make your station as safe as possible. Take into account other things that you may need to be able to consider, such as the weather and whether, if it's going to be raining in the area, you need to deal with all of the power that you're dealing with in those situations as well. So plan it out as much as possible. Do a lot more planning than just getting out and throwing up a station and operating. It'll help you as you build out this plan for field day to be more effective and more efficient and a lot safer throughout the rest of the year as well with all of your operating. With that, I think what we'll do is we'll wrap up this week's episode. Say thanks for everyone who's joining us on the live streams. If you're here inside of the Zoom for the live audience, hang around. We're going to do the after party. We'll open up the mics and we'll take some questions with that. So with that, we'll say 7-3 to everyone on the live stream, and we'll see you next week.